Hello students, welcome back to my channel once again. So today we will be covering the CBSE board grade 9. The chapter is circle. So this is the part 1 video. Since you know that circle is a big chapter in grade 9, so there will be many more videos that will be coming soon. Okay, so I have divided this circle chapter into different parts so that you can understand it better. Okay, now let's dive into it. What first we will see what circle means that you already know, but we will again revise it. Then we will also do some theorems and including the proofs of it, and then finally we will move ahead with the some problems applying the theorem. Okay, so let's dive into it. So what what is circle? So before we go ahead into the circle, so let us see some examples of circle from day to day life. Okay, so this is bangle, this is ball, coins, boundary rope of a cricket ground. Now you have to identify which is circles over here. Now if you take a look, bangle, that is a circle because bangle, the internal part is not there, only a outside part is there. That is bangle is a circle. But out of these 4 examples, here 2 examples are wrong. Which one is wrong? The ball, that is not in the shape of circle. That is a 3D shape. In turn, we can say that is a 3D shape of a circle, which we call it as a sphere. Next, coin. Coin is also having a 3D shape, right? So that's why coin is also not a circle. But boundary rope of a cricket ground, that is a circle. So in this case, 2 examples are wrong, that is ball and coins. So why are these examples wrong? For this, let's understand the definition of circle. So now we will first take a look what circle means. So here what do you observe? That a circle with center O. Okay. Now let us define the circle. So circle is a set of points in a given plane. Can any of these points in plane be called as a circle? So let's see these points like whatever is given inside the blue one, cloud one. Okay, can we say these are the circles? Because earlier it is mentioned that circle is a set of points in a given plane. So that is not the complete definition. I will come to that part later on. So are these set of points are circles? No, these are not the set of points of circle. So now each of these points here should also satisfy a condition. Then only we can say that it should be a circle. So what is that condition? Let us understand that first. So let us take a point A. Okay. Now let us measure the distance from O to A. So we got 4 centimeter. Now we will take another point B and also take measurement of this OB. We will again get the same 4 centimeter. So in this way, let us take another point C and the measurement will be same 4 centimeter. Another point D, this is also 4 centimeter. Another point E, so this is also 4 centimeter. Okay. Now what can you say about OA, OB, OC, OD and OE? So these all are equal, right? So all these points are equidistant from a fixed point. So if you take a look that A, B, C, D, E all are equidistant from the fixed point that is O, right? So when we define circle, we have to mention that circle is a set of points in a given plane which are at a fixed distance from a fixed point. So we can only say that the circle, that is normally we call it the boundary one. Okay. So the circle is basically if we draw many point from a fixed point, and that should be always fixed distance or equidistance. Okay, then only we can call it circle. So this fixed distance is called the radius. Now in this case, what is OA? We already know this OA is the radius. Now how many such radii? Radii is basically the plural form of radius. So how many such radii can we draw in a circle? So we know that since there are infinite points in the circle, so from O we can, if we join a line from O to the infinite points of the circle, then we can draw infinite radius. So remember, radii of the same circle are always equal. Now let us understand few more elements of circles. Let us consider two distinct points C and D. Okay, so we have considered two distinct points C and D on the circle. Now let us join them. So what do we get? We get a line segment, the CD line segment, right? So such a line segment is called a chord. So if we go with the definition of the chord, so a segment joining two distinct points on a circle is called a chord. Now how many chords can we draw in a circle? That is also infinite, because in a circle there are infinite points, and infinite points if we join, you will get infinite segment. So how many chords? That will be also infinite. Now look at here. We have considered 2 points P and Q and we joined them. But here there is something extra feature over here. That is, when we join P and Q, it also pass through the center O, right? So this is also a chord, but this is a special type of chord. Okay, what is called this special type of chord? That is called as a diameter. Okay, because so if we go with the definition of a diameter, diameter is basically a special type of chord which passes through the center. So such a chord is called the diameter. Now a chord, if we go with the definition, a chord passing through the center of the circle is called a diameter. So how many such diameters can we draw in a circle? So since there are infinite points in a circle, so we can draw infinite diameters. And one thing you have to remember here, that diameter is the longest chord in a circle. Okay, so you can't draw bigger than that. So that is the longest chord of a circle. So diameter, how many diameters we can draw? That is infinite. Now let's come to the theorem. So the first theorem is equal chords of congruent circles subtend equal angles at their center. So here we are introducing a new term called subtend. Subtend, I will explain, don't worry. What do we mean by subtend over here? So here one thing is given, that congruent circles. Okay, so let us draw a congruent circle. So first, before we draw the congruent circles, we have to understand what congruent circle means. Congruent circle means which have the same radius. Okay, so we have drawn two circles with the same radius where the center is different. One is O, another one is P. Now here there are two chords that are equal. Okay, so we will draw one chord AB in the first circle and then another chord BC in the second circle, which are equal. Now there's telling that what is given in the question, first we need to write that. Whenever there is any type of proof, first we need to always write the given. So here what is given, that AB and CD are two equal chords of congruent circles with center O and P respectively. Now here what we need to prove, that it subtend equal angles at their center. Its subtend means which one? The chord will subtend means it will make a equal angle at the center. So that means first we need to understand what is the angle subtended by chord AB at the center. So means what is the angle AB is forming at center. So that is first, this is the AB chord. Subtend means we have to just join A with O and O with B. Whatever angle it is making in the angle, making in the center, that will be the angle, subtended angle. Okay. So we will name it as angle AOB. Okay. Now we have to prove that they are making the equal angles at the center. So this is the first circle angle. Now let's take a look at the second circle angle, subtended angle. So angle subtended by chord CD at the center is, similarly we will join CP and PD, we will get angle CPD. Okay. So we have to prove that angle AOB is equal to angle CPD, because that is the theorem they are asking, that we have to prove that subtend equal angles at their center. Okay. So given and to prove, first we have written. Now we have to understand what we need to prove over here. Means how we are going to proceed with the proof. So for proving the angles equal, first thing what we need to do, we can clearly see that here two triangles are forming. One is triangle AOB, another is triangle CPD. If we can prove that these two triangles are congruent, then we can easily prove that angle AOB and angle CPD will be equal by using the CPCT, that is corresponding parts of congruent triangle. Okay, now let us come to the proof. So how we are going to prove it? Now in triangle AOB and triangle CPD, if we take a look, AO is equal to CP. Why? Because we know that these are the radius and congruent circle always has the same radius. So AO and CP will be same. So radii of the congruent circle, that is always going to be equal. Similarly, OB and PD will be equal because they are also the radius of the congruent circles. Now AB is equal to CD, that is given in the question, right? It is already mentioned that equal chords, so it is given. So by SSS criteria, we can clearly say that triangle AOB is congruent with triangle CPD. So now by CPCT, that is corresponding parts of congruent triangle, we can clearly say that angle AOB is equal to angle CPD. Okay, so that's the proof. This is the first theorem. Now I'm coming to the converse of this theorem. So earlier it was mentioned that equal chords are making equal angles subtended by the center, at the center. Now here it is already mentioned that the chords of the congruent circle subtend equal angles at the center. Now we have to prove that the chords will be equal. So it is just the opposite of the previous one. So let us read the theorem. If chords of congruent circles subtend equal angles at their center, then the chords are equal. So again, congruent circles is given. So let us draw this. Okay, with a different center O and P. Now here chords are given. So the first circle, let us consider the chord as AB and second one is CD. Now they are making subtending equal angles at their center. So angle subtended by chord AB at the center is angle AOB. Similarly, angle subtended by the chord CD at the center will be angle CPD. Okay, so it is given already that AOB is equal to angle CPD. Now what we need to prove? In to prove, we have to prove that AB is equal to, chords are equal means AB is equal to CD. So for proving chords equal, first thing we need to prove is that prove the triangles are congruent. So now let's come to the proof. So let's take triangle AOB and triangle CPD. So in this case, AO is equal to CP because they are the radius of the congruent triangles. Congruent circles. Now, angle AOB is equal to angle CPD. This is a given. So we'll write given. And AOB is equal to PD because this is also the radius of the congruent circles. So by SAS criteria, that is side angle side, we can clearly say that triangle AOB is congruent with triangle CPD. Now by CPCT, that is corresponding parts of congruent triangles, we can say that AB is equal to CD. So we have proved the converse of the first theorem also. Now coming to the another theorem, the perpendicular drawn from the center of a circle to a chord bisects the chord. So let us understand the question first. Perpendicular drawn from the center of a circle. So let us first draw the circle and consider the center as P. Now a chord is given, that is AB. The perpendicular drawn from the center. So if we draw a perpendicular line means perpendicular means it will make 90 degree, right? Perpendicular is it will make 90 degree. So let us draw a line from P to the chord AB and it will intersect at point E where it is making a 90 degree angle. What we need to, this is given. Okay, so let us first write the given part. So we will write in a circle with center P. PE is perpendicular to AB. So this AEB, we can see that this AEB, now here what we need to prove that this bisects the chord, right? So bisects the chord means, bisecting means dividing into two equal parts. So bisects the chords mean chord will be divided into two equal parts. So here AE and EB, we need to just prove that because A is the point where it intersects the chord. So AE will be equal to EB. So we have to prove that AE is equal to EB. Now for proving these sides equal, first we need to prove the triangles congruent. Okay. Now here can we see any triangles? So once triangles are congruent, then we can easily prove that remaining parts of the automatically will be equal, right? So first we need to find the triangles over here. So do we have any triangles over here? So there is no triangles formed, right? So first we need to create this. So we will join point A with P and P with B. So now we can see there are two triangles forming. So this thing, since we have drawn something, so that will go in the construction part. So we will just write that draw PA and PB. Now coming to the proof. So now take triangle, these two triangles, okay. Now triangle PEA and triangle PEB. So already we know that angle PEA is equal to angle PEB, that is 90 degree because P is the perpendicular of AB. So this is given. Now PA and PB, what are these? If you take a look, triangle PEA is nothing but a right angle triangle. So in right angle triangle, PA will be the hypotenuse, and so PA and PB, these are also the radius of the circle, right? So here we found out that PA is equal to PB, that means these two hypotenuse are equal. And in the condition you will write that these are the radii of the same circle. Now P is the common line over here, so you will write P equal to P, that is common side. So now by RHS criteria, that is right angle, hypotenuse and side, right? So by RHS criteria, we can say that triangle PEA is congruent to triangle PEB. Okay, now by CPCT, so we can clearly say that AE is equal to EB. So that is what we need to prove. So we have prove the second theorem also. So there are so far we have done actually three theorem. First one, the second one is just the converse of the first one, and then another theorem. Okay. Now we are going to solve some problems based on the theorems. Okay. Now let us take a look at the question. So now we will use the theorem and solve this problem. So the first question is the radius of a circle with center P is 25 centimeter and length of chord is 48 centimeter. Find the distance of the chord from the center P of the circle. Okay, so let us take a look at the circle. Okay, so the radius is given with the center P, that is 25. So here AP is 25 and length of the chord, that is AB, that is 48. Okay, now what we need to find out, we have to find the distance from the chord from the center P, that means PM we need to find out. So now what is given, first we will write in a circle with center P, PM is perpendicular to AB and PA is equal to 25 centimeter and AB is equal to 48 centimeter. Now what we need to prove, this is not a proof. What we need to find out, we have to find out PM. So we will write to find PM equal to what? Okay. So we know that now we have to apply the theorem that we have learned earlier. So we know that perpendicular drawn from the center to the chord bisects the chord, right? So now we will write that PM is perpendicular to AB. So AM is basically half of AB because AM bisects the chord into two equal parts. So that's why AM is basically the midpoint of AB, right? So bisects means AM will become the midpoint. So AM equal to half of AB. So also we have to mention why it is half of AB. That perpendicular drawn from the center of the circle to the chord bisects the chord. So whenever you are solving this type of problem, always mention which theorem you are applying. Okay, if you don't mention the theorem, then you will not get the full marks. So A will be equal to half into 48, that is 24 centimeter. Now consider the triangle PMA. So we can clearly see that PMA is nothing but a right angle triangle. So angle PMA is 90 degree. So we can easily apply the Pythagoras theorem over here because we know the AM, that is the base, and we know AP, that is the hypotenuse, and PM will be the height. So we can easily apply the Pythagoras theorem to find the height. So PA square equal to PM square plus AM square. So now we will also mention that which theorem here we have applied, that is the Pythagoras theorem. So 25 square equal to PM square plus 24 square. So PM square will be equal to 625 minus 576, that is equal to 49. So PM will be square root of 49, that is 7 centimeter. Okay. So the final answer is distance of chord AB from center P is 7 centimeter. Now coming to the second problem. AP equal to 34, AM equal to 30. If AM is perpendicular to PQ, find the length of PQ. Okay. So here what is given? AP equal to 34 and AM equal to 30. So let us mark this, and AM is perpendicular to PQ. So in a circle with center A, AM perpendicular to PQ and AM is equal to 30 and AP equal to 34. Now we will have to find what we need to find, PQ. So that is the chord. Okay. So how we are going to solve? Again, here also we need to apply the theorem. So let us consider triangle AMP. Okay. So before we apply the circle theorem, first we need to find out the PM value. So in triangle AMP, angle AMP is equal to 90 degree. So here we can apply the Pythagoras theorem, that is AP square equal to AM square plus PM square. Okay. Now 34 square equal to 30 square plus pm square. So that is pm square will be equal to 256. So pm will be square root of 256, that is 60. So now we know pm. Now we have to apply, we have to find PQ. So here we will apply the theorem that we know that perpendicular drawn from the center to the chord bisects the chord. So AM is perpendicular to PQ. So PM will be half of PQ. So here also we need to mention the theorem that is perpendicular drawn from the center of the circle to the chord bisects the chord. So 16 equal to half of PQ. So PQ will be 32. So here since no unit is mentioned, so final answer you should write it that length of the PQ is 32 units. So nothing is mentioned means you will write just the units. No centimeter or meter anything. Okay. So that's all for today. Okay, we will come up with more videos on the circle. Don't worry. We'll cover everything one by one. So keep patience and please, if you like the video, please hit the like button. And if you have any questions, you can always put that in the comment section. And please share this video with your friends. And to get the upcoming circles videos lectures, for that you need to just subscribe to my channel and then you will get the notification whenever I will be uploading any new videos on the circle. Okay, that's all for today.